N. Ramani worked at the ISRO Satellite Center in the areas of software development for spacecraft mission operations and in the establishment and management of the Central Computing Facility. Led the activities relating to the design, development, testing, and implementation of software for real-time health monitoring and control of satellites. Pioneered the transition from mainframe world of Fortran and assembler codes to distributed computing based on off-the-shelf systems with the best of the breed engineering application software packages. Worked on computer-related issues that have overall impact on the organization, such as information security, software reliability, manpower attrition, open source and HPC. With Professor N. Narasimha, carried out the Indian Airline AVRO HS 748 fleet performance simulation for the airworthiness assessment for the National Committee headed by Professor S. Dhawan. Worked on several government committees that enable the computerization plans of ADA, CBDT, EPFO, and MES and SBI. He was awarded a Distinguished Aero Alumnus of the Department of Aerospace Engineering of the Indian Institute of Science and an Astronomical Society of India Award in 1999. He was recently completed and validated a 3D missile trajectory program which can provide the path of the missile from any launch location to any target.
To all of you. Chandra in his presentation was mentioned about two software packages that we have developed at NIAS. One was about, given the set of the parameters of the missile, such as how many number of stages are there, in each stage what are the, what is the propellant that is carried, specified in terms of the specific impulse, and such as those, converting to its performance, what kind of range it can reach, if the target is within the maximum range that it can do in a direction, can it reach the target? Can it reach by a shallow trajectory, which is hugging the surface of the earth, or a lofted trajectory? They have both their own advantages and disadvantages. So that is the purpose of the first software that we developed. That has been used extensively by Professor Chandra as well as some of our colleagues. Whereas the second software, which has a much versatile application area, is the one what we call as the in the domain of space situational awareness. That is, in terms of ISR, it is in intelligence, surveillance, and reconnaissance. What kind of capability that your enemy possesses? To be able to determine that, we have developed a software. Let me give a narrative about how does it start, then how do we interpret the results, what comes out of it. Now it has a very excellent GUI, which makes the life of the user very simple. We called it as VNIVDVC for the lack of a better word. The reason being, otherwise I should have used Tamil or Hindi. So, but then we prefer to use some language which we didn't know. But it has it has a good meaning. VNIVDVC means that came, saw, conquered. Well, it has a connotation which fits into this thing. As I clicked on the icon which was there, it opens up with a simple display which consists of two parts. On the right hand side is the three-dimensional view, on the left hand side is the two-dimensional view, and it has a screen something like this. So there are, like similar to any simple application like even Word, you can recall an existing configuration, you can edit it, save it, or totally construct a new configuration. So the moment you say simulation, it asks whether you are going to run a new simulation or you are going to use one of the existing simulation. Let us see what that, if I identify by a name, for example, this is the local area, this is a set of 26 satellites which are identified from the Yogan constellation. Yeah. There are, now, this particular configuration has 26 satellites. All are from the Yogan name, because what we are trying to do is trying to run by this simulation, we are trying to assess what kind of capability the China possesses. That was presented in detail by Chandra. When we say what kind, they have large number of satellites, but we have taken a particular subset because based on the analysis, one can either introduce more satellites into this, which means joining more resources from what is available in the kitty, or you can drop out some of them and see whether there is a degradation in the terms of coverage. Now we have recalled this, the process of validation. I will come to the more nonsenses of this software a little later, but let's first see the way in which we can start the run and complete a successful simulation of this. Now we have recalled this. Now it said that there are 26 satellites to begin with. If you want to look at all the satellites that have gone into this, this is the list of all the satellites, and you see that the sensor that it carries is the L-int, right? L-int has two parameters. These two parameters can be defined with respect to a reference altitude and a reference slant range, or if you don't have that information, you can simply substitute 0, 0, which means it will compute horizon to horizon coverage. So, which is the computed taking into account that the value input is 0, 0, right? Now, if you want to add a satellite, right, we can add from here. But instead of going into the books and finding out, now supposing I try to add one of them which is already there, it should certainly, first I have to edit this. I wish to edit this particular configuration. They all will run like typically in same lines as any other software, like Word or PowerPoint, whichever it is. So supposing I want to add a satellite called, first of all, satellites are identified by the NORAD number. NORAD number is the unique identifier. There are other methods like international designation, but NORAD number is universally used. So this is a database which is run by the NORAD, which gives for all these satellites, there are what are called the two-line elements, and there are also the three-line elements. Three-line elements are basically the two-line element plus the name of the satellite. Now let's first begin with a particular number 3901. If I enter this, it should say there is an error because it's already there in the fleet that you have chosen, right? So it doesn't let you do that, but let me remove this for the convenience of 3901. If I enter this, it should be able to accept now, because I knew I want to maintain that. Now when I click validate, because all human input errors are, human input are prone to errors. So NORAD number being 5-digit number, any 5-digit number looks like any other 5-digit number. So 39011 is what we saw, it was there already. So, and it says now it goes to the database of this three-line element, fetches that satellite name and displays it, so that in the expanded form, you know whether this is a satellite you meant. Now what you see is mostly trivial general knowledge approach to designing a software, right? First of all, the input must be free from errors. We are making sure that if this information is flashed, the user pays attention to this and says, yes, this is what the satellite I want. So after that, he defines whether it is an optical satellite or source center or else a L-int. So now if you choose L-int, the reference altitude or reference slant range, now that means this is acceptable. It has accepted this. However, this satellite visual characteristics have not been defined. This would have gone to the very end possibly, right? So now we have to, yes, I define this as this and then save setting. Save. Now that means I went back to the same old configuration only after demonstrating how easy it is to input a new satellite into this. Okay. Now then after defining the fleet of satellites, we have a method of defining the targets. The targets are There are three types of target. In fact, four of them are there. Point target, which is a fixed point on the surface of the Earth, which is latitude, longitude. And that I have chosen now for the purpose of study, which we have done now, Okinawa, Guam, and uh, eh? Taipai. Taipai is the other thing, three things. And there are latitude, longitude is defined. And point moving target is possible. That is, it starts with a position, latitude, longitude, and you can define the waypoints. You can define it by about 6 waypoints, so that the target is moving. It could be an aircraft carrier or whatever that is. And generally, aircraft carrier is defined by an area, because it's not a single element which moves. It is an entire configuration which moves. So it is normally defined by an area. But whatever is the definition which is given with particular movement in a direction, the area target is, it can have 6 vertices to a maximum. It can be up to 1000 nautical mile by 1000 nautical mile area to a resolution of 1 nautical by 1 nautical mile. Now, having done all this, then we have defined 3 point targets, and we have defined yes, one area target. Now we are ready for starting the simulation, right? If we start the simulation, now it fetches the database. At this point, I should mention it can function both online, which means it will access the NORAD database in real time and fetches that information from the NORAD database. Security organizations don't want this to be known to the owner of the database, so it's possible that they can download it offline and present it as a file, so it will read from a local file. In order to be able to read from online, obviously you need the internet. Many security organizations will not like that to happen. So this can function without any interruption to the simulation that it carries out, without referring to the online data, which means it doesn't require an internet connectivity. Now, because there are too many of these satellites, obviously this color configuration also is a bit funny. So what we can do is, we can shut down many of them for display purpose. The simulation will be carried out for the entire set of 26 satellites which are given. In order to avoid the cluttering, we can choose, there is a sluggishness in the way in which it is progressing. What it does is, now on the left hand side I opened up another panel in which we see the parameters of each satellite, and one of the parameter that I am changing now is the display characteristics. I say that it need not be displayed, so which essentially means the circular coverage will not be seen, but whereas it is taken into consideration for all computations, right? I'm sorry, the response is a bit slow, so pardon me for a little bit of time, so that if it becomes, yeah, but I'm trying to switch off one by one. When we do that, the display quality will certainly become better. If you have a better computer, better processor, display, etc., this can certainly improve. Now, yeah. Now, in the meanwhile, you can look at the set of parameters which are there. It gives the NORAD ID and the present latitude, longitude of the satellite, and a whole host of them, including what are the characteristics of the orbit in which it is, etc. Now, assuming that we have done all the display characteristics which I want to choose, we have chosen. What we want to shut down, we have done. Assuming that, let's look at the other parameters that we can monitor in this. Let me do it once. I will switch off one more. Okay. Right. I'm just shutting down this particular display. Right. Now we see that these 2-dimensional, 3-dimensional displays are there. it is possible that you can mix and match them in the sense you can ask for entirely a two-dimensional view of this, or entirely a three-dimensional view of this, or you can even look at without the display parameter, other things. You can see the full display a part of it. Still, it's very cluttered. We need to do only one thing. For that, we have to switch off more satellites, and that can be done anytime by opening up more. I think unless we do some more. Yeah, now because some satellites have been shut down. Yeah, now one more display update, it will bring it to the right order. Meanwhile, I will mention about there is another panel which is hidden that opens up with the what is called the simulation rate. Simulation rate, now at this point in time, the integrations are carried out at once a minute, which is optimum as we have figured out. But it is also possible to, you can run this 10 times faster, 20 times faster, etc. Faster depends on, obviously, already it was struggling to run this at the normal rate. So you obviously cannot run it faster than this. But at least it will do one thing. The resource squeeze takes place more from the display. So what it will try and do is, it will display, supposing you choose 30, once in 30 minutes only the display will be updated. So that the resources saved for that purpose will be used for the computation purpose. Then we have the pause and we have the stop button, right? So still we can try and do it at, say, I have set it as infinity, so that I want to go to the next stage of, now you have two other sections of the display, satellite, target and observer, which is essentially, if you go to the satellite, I should be able to see all the satellites so that I can choose any particular satellite with which the entire display will be centered. See, because the panning takes place all the time. So the panning is centered around a chosen satellite. Or it is possible that you can choose this with respect to a particular target. Or you can choose to center it with respect to this, it says it's not done yet. That is the observer, we didn't also input. So here are three other buttons. They provide you an opportunity to place your target wherever you want at the runtime. The other targets that we saw was, it is to be predefined before you begin the run. Now here is an opportunity, depending upon the progress of the run, it is possible that you can select this and position it in some place. For example, I can choose, place this in the current map. Should be able to do that. Let me, yeah. So this is with respect to, you can place a target in a particular place, it will be taken for consideration from then on. Right. Now, what else I need to say? Well, okay, we have now set it as infinity. So the simulation, when it comes to a close, what we saw so far was only a display. Display is only for being impressive for a person who looks at it, doesn't hold any, gives any strength to the analyst. So what we need is actually the information about what are the coverage patterns with respect to every satellite, with respect to every target, every satellite, how does it look at? What are the accumulated display percentages? All these are available when the run completes. At the end of it, we have a report which is generated, which give presents this information. Now, yes, the simulation reached because we made it faster. It is a one-day simulation which has completed in about 5 minutes. So I can close this. Yeah, I'm looking at this simulation that we did was with respect to, yes, this one. And there are two files which are generated now, which are, is this a run or 26? Sorry. Yes. This presents all the details that were presented by Chandra in terms of this is listed out in terms of sequence of events, which means the first event started at 4 minutes, 8 4 22 to 8 4 1203 to 12 to 1203, which is for a period of 4 minutes, and it is the target is Tai Pai, and the satellite that saw it is Yogan 31K, etc. What we collect, what was presented by Chandra is selected columns of this. If this is too clouded, we can remove certain columns, or if some information is missing, we can always add. Because basically during the simulation, every aspect of every satellite looking at every target is collected. So it is a question of what we want from this output. During this time there was a question about whether such and such characteristic of a target can it be recognized by this. While certainly the corresponding sensor has to be capable, but we have some feedback from one of the major users. In fact, Navy Bombay is using this software tech. So the same response which comes from them is both positive and negative for the software. One is they have taken this whatever gap it shows seriously, and they are of the opinion that whenever you want to switch off or whenever you want to switch on, we can't do that. Our operational considerations are different. Which means if you say that there is a possibility that Chinese satellite will be looking at you, they are taking it seriously, right? So that is why they, on the face of it, they don't agree to that. The other one is that at the same time, if they say that you cannot control them when they want to operate, the software itself has no value, right? Because you are saying at such and such time it's going to be seen. They don't want to take this seriously, but you can look at it either way you want. The fact that whether this particular sensor can be particular characteristic of the sensor can look at particular characteristic of the target is a point that you can debate, and correspondingly, as long for anything that any target which has a certain characteristic, correspondingly there has got to be a sensor, right, sooner or later, which will be capable of picking it up, and that is what has to go into the onboard characteristic of the satellite. Now I will stop at this point, and I am ready to answer any questions if they are, and if somebody wants to take it up on a separate independent session, I am available. So I am willing to spend some time with them. Thank you very much. That is not our concern. No, but we have put in so much of satellites from China. But if you give us any other set of satellites, the space set as we call, the same thing can be run. No, 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 this is available. Most probably, you see, what is the hardest part if you ask me? I can go through this. This software anyone can develop. It's not a big deal. There are lots of commercially available software, except that fortunately they are so prohibitively expensive. Nobody can even touch with a barge pole, correct? So they cost millions of dollars. Obviously, this doesn't compare favorably technically with them. This is some kind of it's a beginner's paradise. So now, whereas if such a thing has to be done, anybody in the university can also do that. There are some tricky portions in this, which possibly, if somebody puts a patient thinking, can certainly do it. I am willing to handhold with them and tell them how this is done. Yeah. Yes, sir, please.
Know that it's a alienate or any type, what type of sensor they have. So does the because En-ROAD I think it have the details of the satellite. So the software retrieved it from there, or it has to be fed by the user itself.
See, NORAD ensures that for all the satellites which are there, except their own spy satellites, they make available the orbital information about all the satellites. Obviously, about Chinese, they have all the information published. Now, what do they guarantee? They guarantee a certain accuracy. At the epoch is the reference time at which they publish the orbital element. It is better than 1 kilometer. And it decays at the rate of 3 kilometers a day, depending upon the orbit of the type of the orbit. For example, something like space station decays once in 4 hours. It exceeds the error limit which is acceptable. So what they do is, using the tracking data of those 4 hours, they will update that information about the orbit. Right? Now let me complete. What it means is that NORAD updates it as and when necessary. Necessary for what? They guaranteed a certain accuracy. Always they comply with that statement. Right? They will, as and when it is likely to go out of the accuracy promised by them, they make it available. Then what do? As and when available, we take it. So that means we assume that it was necessary, so NORAD did it. So because NORAD did it, we take it. So we are in a process of online contact with them all the time. In the sense, not with them means what? It's a machine. So there is a database, you make a query. So that query part is generally, this is published information available for single satellites. To convert it to 30 satellites, that requires quite a different way of looking at the same software which is there for a single satellite to multiple satellites, and interleaving them with the time step movement as well as satellite changes, target changes. That becomes a bit clumsy.
Sir, I just add one.
Please.
Sir, Chandrashekar sir was mentioning that the same software can be used to predict. Like this is the thing that is run, that happened. But the prediction part, if that can be shown.
It can do prediction. For example, if you have, if you want to predict for say next 3 days, right? Obviously, you are making a prediction with respect to the even orbital information. Then you are governed by how much accurate results can be got from a theoretical model that you have computed using. See, if it is about the past, it must have been improved with the tracking data. If it is future, it is only a prediction right through. It decays at the rate of, as I said, per day it will be something like 3 kilometers. If you are willing to accept that kind of inaccuracy, that's fine. So nothing more can be done by anybody for that matter, because you need an orbital prediction theoretical model, right? This is one of the best theoretical models that is available, right? When we sit down to
off by 10 minutes. It's a pretty orbital. They're going to be.
Yeah, you can see it in another way. The way in which the results were presented by Chandra, it reached that 88% within about few hours. It remained so right through full day. So whatever I make in the past, say let us say what I did for last week, is going to remain the same for next week also. That's another way of looking at it. Because if you make a prediction, be sure you are introducing theoretical errors. Because no model is perfect. Even NASA cannot produce them, they can only make it better. Yes, sir, please.
Always a fear that the GPS could be interfered with certain wave propagation from the ground. And there was also detected interference with the GPS satellites. with so much of information that you are able to derive mathematically or through your programs, would it not be possible to interfere with those satellites and see they don't look at the target?
Generally, if it is a communication satellite, you possibly can,
Jam it.
jam it. But then they have other methods of escaping from the jam. It is counter.
Yeah, counter
that
going on. Even
it's
now.
but I only, neither I am good at answering that question, nor I can handle that in the program. So,
very useful way, you know. So the geography is either as anti about your opponent doing a baseline. So my point is, Ramani is very modern. I can tell you that whenever we want to look comes with it. Most of the time I know that the methodology, so it is not super duper. I would argue that argue again. Accept that. You can argue so many ways. There is not about fact, largely. Yeah, so my point is, it's not that know a lot about.
Particular software we're talking about, how does this augment, or in what way is ISRO's recent center known as IS40M, how is that connected to this function, and how does that function or that center take this particular operation forward?
I mean, this particular tool, how is it? They do it, as I know, in the particular case where a particular Navy unit is using it, is when they want to do what do you call as the demonstration? No, it's not called a demonstration. They want to do a rehearsal. They want to do a rehearsal, right? Wargaming, yeah, that's more precise. So then that is the time which they would, if there is a possibility of a satellite, Chinese satellite in that contingent is likely to pass over, you stop doing that gaming. So that's what the operators objected to that, saying we can't keep shutting off on now and then. Okay, so which means if they don't shut off, that means the satellite can pick up. That is their fear. That's why they refuse to, at one viewed from one point of view, they are aware of the fact that if they put it on, right, as I said, Ellent cannot, it is something like saying ship is the safest on land. So aircraft carrier will certainly safest when it doesn't emit. But that's not the role. It has to do something. No, hypersonic, yeah.
You're actually doing it from on the other side of the. Now you could have something in low Earth orbit, like 200, 300 kilometers, and through minimum maneuvering, you can actually come and re-enter it from any part of the world. So my argument about the hypersonic, here we are looking at an ISR problem. It is only to know where a target is and how do we go. If we are not looking at defending against any, all the other things for offense or defense you have to do based upon this information. So this only provides information. Right? It does not address the larger issues of war.
Two things. The first one was regarding the satellite, doing work when the satellite is not above your head, so that you can avoid being detected. I am reminded of what India did 24 years back in Pokhran, right? We avoided all the American satellites when we were doing the work. So that was one thing.
I am sure an astrologer has helped them.
Sorry?
An astrologer has helped them. There did not exist any capability at that time to do this.
And there were much less number of
You are referring
satellites.
to the Pokhran.
Yeah.
That is, there existed no capability of this kind.
Yeah.
Certainly not.
Yeah, and now with the a gap of only 2 or 3 minutes between the visit of the satellites, you cannot do that anymore. That is.
That's what.
That's what.
First, I argue that the American the problem was in my more like an organization. Here also we are working on the possible organization. Or when you say political something else.
Yeah,
Sir, my feeling is if I stretch my neck out, I don't think the Americans did not know about it. They knew. For their own reasons, they didn't bother about it, ignored it, or did not share this with others.
Anyway,
There is
that was
nothing
the.
that can happen without their knowledge.
Anyway, that was the story that came out at the time, and so I'm
Kalam
reminded of
did it
that.
and things like that.
The second point I wanted to make was regarding the NORAD data that you are getting. Now, don't you think that India should invest in SSA,
Absolutely.
in SSA kind of thing, so that situational awareness of
So
space?
Professor Ramurthy had the answer. You should have woken up for this 100 years ago. So now if you come up and start this, I don't know when you will be ready.
This really have not made this investment, but after we produced our first report, ISRO has now gone up and set an office for space situational awareness. Huh? It is not called, but so they are doing it. My point is you need to make a lot of investments. There is also a new possibility. The Americans, and I'm sure the Chinese also, they have put satellites in orbit that can look at other satellites. Yeah, so I think that is also a possibility. And in a sense, it will be a easier possibility than this thing we have also presented to ISRO. I have a report which I have presented. All of it is covered, but what they are doing, of course.
Sir, that is easier as he said. The easiest method is to get into collaboration with NASA, which we are very good at.
No, but we know that ISRO is doing that kind of. We know that ISRO is keeping track of the objects in space because of their own launch. Should not get interfered.
No, where are they? Do they have an independent capability?
Yeah,
the answer is no. No.
But like what?
That I can challenge, because the only software that they have which can do this is an American software called the STK, right? That's what I said as $1 million. So whatever it is, they don't have the capability. They have a director for a center which is created, right? I don't think they have a wherewithal. They are always after what's called the high precision data. It's nothing but collaboration with them and getting it in the way they want. They can always find ways and means of achieving the end goal. But yeah.
No, but so that reminds me of the damage that was done to India's RISAT-1. Was due to a space debris that the JCPOA, the Joint Commission of
Same thing as NORAD.
they detected about a month before that happened.
Calibrate. See, RISAT, the Indian, so there are two RISATs, I always get confused between them. The Indian RISAT, the Indian built SAR, had this huge solar panel because SAR requires a lot of things. So I think one of the RISATs, which was Indian built, started shedding. You know, because of the size of the panel and because of the orbital issues and the solar panel, I don't know what the other things were, it started shedding a lot of debris. Okay. So one of the problems with RESAT, one of them at least, was the debris problem that it was creating. NASA was pointing out that that was the problem. Now this fact was not reported in India. Okay, it is only known to NASA, and I think a limited international kind of circle. I happened to read it somewhere because somebody sent it to me, so I kind of came to know about it. But this is one part of the story. So the debris that the RESAT created is actually self-generated debris in a sense. Okay. So I think that is the real picture, and ISRO does not officially acknowledge it yet.
You are right, sir. Every missile rocket launch of ISRO is to be preceded by what is called the conjunction analysis, right? That they get this information from somewhere from NASA only, right? They must have a collaboration, or if you are willing to spend more money, conjunction analysis report will be produced by an independent company. Why you need to get the data, compute, and go wrong in that? You can get the report itself.
But American, they are sending create the space situation awareness.
No, nothing but they are tracking satellites. You carry out the tracking instead of from ground, you do it from satellite. So you have much better coverage.
You can do differently. You look at a large spectrum. What particularly you want to look at, understand what it is.
Accuracy of the orbit is based on the geometric segment that covers, which can be done as long as you are talking about the ground-based tracking. The ground stations must be distributed geographically. That may not be many times possible because it may not be in your soil. So space-based observations are much better.
1.5.
They go wherever the requirement launch or a particular, wherever there's a rocket launch, they are going back to the point. They have a major missile tracking. They definitely can record all the data, objects, and all. They are actually. So they must have gone to Sri Lanka largely for replication. That is really it. Time that is they never.
I just want to say one thing about the Taiwan analysis which Chandra did. What did they demonstrate? Chinese demonstrated they can do a precision bombing in and around Taiwan, right? But when do you bomb? Unless there is a target there, right? That's what this particular analysis is likely to fill.